Welcome to the webinar 50% pesticide reduction. Mission accomplished or time for a reliable indicator? My name is Martina Sordian, former project coordinator at Global 2000. I'm going to guide you through this event by telling you the agenda. In the first place, we're going to listen to Martin Dermine, Executive Director of PAN and spokesperson of the EU Citizen Initiative Save Bees and Farmers, presenting how pesticide reduction is faked with the HRI1. In the second place, we're going to listen to Maria Zintl, plant protection expert at IFOAM Organics Europe, presenting impact of the misleading HRI1 on the organic farming sector. In the third place, we're happy to listen to a short statement of Aidan O'Connor from the EU Commission DG Santé. He announced this shortly before the webinar. And finally, to Helmut Burtscher-Schaden, biochemist at Global 2000, presenting an alternative risk indicator whose development he is responsible for. The last part of around 20 minutes is reserved for Q&A plus discussion. In this webinar, we want to tell you the story of the misleading harmonized risk indicator HRI1. First, and finally present you an alternative indicator developed by Global 2000 and IFOAM to offer the EU Commission and the Member States an alternative to replace the HRI1. For better understanding why the use of the indicator HRI1 leads to fake pesticide reduction, we're going to watch the following short video together.
Did you know that strawberries are sprayed with pesticides an average of 7 times before they reach your table, potatoes 12 times, and apples 30 times? This leaves residues in our food, is bad for the health of farmers, and accelerates worldwide biodiversity loss. That is why the EU wants to, by law, cut the use and risk of pesticides in half by 2030. That's good. What is not good is the method by which this is going to be measured. The method the EU wants to use to measure pesticide reduction is based on the Harmonised Risk Indicator 1, HRI1. But this indicator has 2 fundamental flaws. Let's take a closer look at them. The HRI1 is based on the sales data of about 400 pesticide active substances. These are divided into low-risk, regularly authorized, more hazardous, and not authorized pesticides, and are given corresponding risk factors. The fake pesticide reduction is achieved by risk factor 64, as the following example shows. In an EU member state, 15 tons of low-risk pesticides, 9,000 tons of normally authorized pesticides, and 700 tons of particularly hazardous pesticides were sold in 2020. For the calculation of HRI1, the amount of the more hazardous pesticides is multiplied by a factor of 16, and the one of regularly authorized pesticides by a factor of 8. Added together, this gives the total risk for the year 2020. This is our starting point, and is therefore set to 100%. In the following year, we see no changes in pesticide use. The HRI1 remains the same. However, at the end of the year, a ban for mancozeb takes effect, a pesticide that previously accounted for roughly 20% of pesticides sold. The year after, mancozeb is replaced by other comparable substances. Yet again, there are no changes to the overall pesticide use. What does change, however, is the risk classification of mancozeb. As a non-authorized pesticide, it is now multiplied by a risk factor of 64, and that retroactively. According to HRI1, the member state has therefore reduced the use and risk of pesticides by 60%. A reduction on paper only, without having reduced pesticide use in the field at all. Now to the second flaw, which isn't any less of a problem. Let's compare 2 apple orchards. Both are 1 hectare in size and both are infested with scab. On one of them, baking powder, a low-risk pesticide, is used. On the other, difenoconazole, belonging to the more hazardous pesticides. The two pesticides are drastically different in their application. To treat 1 hectare of land, it takes 7.5 kilograms of baking powder, but only 56 grams of particularly hazardous difenoconazole, a difference by factor 134. The HRI1 is now calculated by multiplying the kilogram amount of the pesticides used by the associated risk factors. In doing so, the HRI calculates an 8 times higher risk for the use of the designated low-risk pesticide than for the particularly hazardous one. Europe's pesticide industry is happy with the HRI1 and praises the indicator as a reasonable way to measure the hazard reduction of pesticides. However, as a responsible policymaker, you shouldn't support an indicator like that to monitor legally binding reduction targets. Fortunately, its weaknesses can be easily corrected. If the retroactive increase of the risk by a factor of 64 is removed, there will be no fake pesticide reduction either. To better represent the actual risks, we must take into account the area treated. To do this, divide the sales volume by a mean hectare application rate. The data we need for this is all available. The result is a robust indicator that shows a reduction in pesticide use and risk only when it actually occurs. An indicator capable of reliably monitoring the European pesticide reduction targets.
Unfortunately, the EU Commission withdrew its proposal for a legally binding 50% reduction target for the use and risk of pesticides by 2030 in February this year, in response to protests from farmers. In July 2024, it published new pesticide statistics based on HRI1, claiming that the EU had already reduced pesticide use by 46%. With only 4% remaining to reach the 50% reduction target. The speakers present, Martin Dermine and Maria Zintl, will now comment on this deceptive HRI1 from their different perspectives before Helmut Burtscher-Schaden presents for the first time a newly developed proposal for an improved and reliable indicator by Global 2000 in collaboration with IFOAM. This webinar will be recorded. If you want to remain anonymous, please make sure to turn off your cameras and if needed, change the name you're displaying. The webinar is organized by PestNu, which has received funding from the European Union's Horizon 2020 Research and Innovation Programme. All views expressed in this webinar are the speakers and not necessarily the view of the European Commission. May I now give the floor to Dermine? See you later for the Q&A session.
Thank you very much, Martina. I will display my presentation to give Pan-Europe's view on the situation. Okay. So yes, I am Martin Dermine, working for the NGO Pesticide Action Network Europe. Pan-Europe is a network of 50 NGOs active to replace hazardous pesticides by environmental friendly alternatives, both in agriculture, but also for the maintenance of towns, like sidewalks, like parks, for instance, where a lot of herbicides are used. We in the office, but also our members, regularly receive phone calls from very concerned citizens because they are regularly exposed to pesticides. For instance, rural area people who live next to sprayed fields. But we also observe that there are a lot of democratic signals that regularly highlight on what citizens ask. Every year, a Eurobarometer is published, and the presence of pesticide residues in food is a high source of concern by citizens. There have been, over the last decade, many anti-pesticides petitions everywhere in Europe. We had in 2017 the Stop Glyphosate European Citizens Initiative, asking to ban glyphosate, but also to phase out the use of pesticides in agriculture. In the last legislature, President von der Leyen organized a conference for the future of Europe. And one of the conclusions regarding the environment is a request to have a significant reduction in pesticide use, while another successful European citizens initiative, the Save Bees and Farmers, asks for an 80% reduction in pesticide use by 2030, as well as a strong support to farmers into the transition towards agroecology. So what citizens demand is very clear, and it is more than time that politicians and decision makers really act. Indeed, since 2009, we have a directive, which is a good directive on the sustainable use of pesticides. In EU jargon, it's called the SUD. This directive imposes to member states to establish national programs to reduce pesticides. It also imposes the implementation of integrated pest management in agriculture, where synthetic pesticides are used as a last solution, while preventative measures have to be given priority. It also foresees the protection of citizens, Natura 2000 areas, water catchment areas from exposure to synthetic pesticides. And it also imposes pesticide-free zones to really protect citizens from direct exposure, which led to pesticide-free towns in a series of countries, but it is still a minority in Europe. And as you might know, this very good directive is extremely poorly implemented by the member states. Another obligation under this directive was to establish a new indicator, a harmonized risk indicator, to measure the use and risk of pesticides, which we have since around 10 years, and which is scientifically flawed, as you could see in the video that was produced. We see also here in a recent publication from the German Federal Agency for the Environment that when you look at the sales of pesticides on the left-hand chart, you see that the sales are more or less stable over time. We observe the same when we, for the member states where the data is available, when we observe the evolution of the sales of the most toxic pesticides, it is also usually stable. Sometimes it even increases. But if you use the flawed indicator developed by the Commission, HRI1, on the right-hand side, you can observe that it gives the impression that the use and risk of pesticides are going strongly down, which is completely untrue and not the reality. So the Commission indeed communicates, and this is a statement by the Commission from last August, that we are reaching by magic the 50% reduction from the Commission that was planned in the EU Green Deal. And we are highly displeased with this misleading communication and the fact that even though the Commission acknowledges, and there are many reports from the Parliament, from the European Court of Auditor, that highlights that this indicator is completely flawed, that the Commission deceives citizens by doing such communications. For instance, here we have specifically applied to France. On the left-hand side, you see the evolution of pesticide use and risk using the harmonized risk indicator. You have a reduction by 32%, while by using the French no-do indicator, which is much more scientific, it's not perfect, but it takes into account the toxicity of the product, its potency, and also the areas treated. You see that there is a status quo or a small increase in the use and risk of pesticides. So in conclusion, I wanted to remind that citizens' demands are very clear, and citizens do not understand why decision makers do not do anything to truly tackle this problem of pesticide use. Second, that the suit obliges to effectively reduce the use and risk of pesticides, but it certainly does not oblige anyone to have a deceptive communication towards citizens. That the European Commission and member states must stop with these practices because they really undermine our democracies by providing untrue, manipulated information to citizens. It really fosters the development of anti-European political groups. And the European Commission keeps saying democracy is a priority, but what we observe in this specific case is that you are undermining democracy. And finally, the European Commission needs to, now that the SUR is over, do as they promised after the SUR is over to revise Harmonized Risk Indicator 1, and also make sure that member states properly implement the SUD, as we will not have a SUR. Thank you for your attention. And I pass now the mic to my colleague Maria Zintl from Organics Europe.
Thank you very much, Mata. Good morning, everybody. So in fact, I would like to give some context from the perspective of organic farming. And as Martin said, I'm speaking on behalf of IFOAM Organics Europe, the European umbrella organization for organic farming and food. So let me start by saying that the use of plant protection products in organic farming is considerably restricted. And it is restricted by the fact that only a limited number of substances is at all allowed in organic farming. And this is defined and laid down in the organic regulation. And then in contrast to this, on conventional farms, farmers can use a large array of plant protection products, and these include insecticides, herbicides, and fungicides. Organic farming, on the other hand, tries to be as little dependent as possible on buying external inputs. And this use of synthetic pesticides is forbidden, and the use of any herbicides is forbidden in organic farming. Now, as we already saw in the little video at the beginning, natural substances, which are is the type of substances that is used on organic farms, they often rely on multi-site mode of action or on an interaction with the crop, and they are comparatively speaking much less problematic for the environment and for humans, but they must typically be used in large total quantities to be effective, and this means in much larger quantities per hectare than their chemical synthetic counterparts, which are often much more effective, but also more problematic oftentimes, even at very small doses. So what we are asking for and suggesting is to find a fairer comparison of substances used in organic and in conventional. And this would include finding a fair indicator for measuring pesticides use and risk. We believe that two substances that are very different when we are comparing them. They are different in their toxicity profile, different in their impacts or on their fate in the environment. Then you cannot only rely on the mass of the substance as the only criterion. And also when these two different substances are used in very different quantities on a crop, then mass only should not be the aspect that you look at in your comparison. So, in other words, just because a very small amount of an active substance is needed to treat your crop, this substance is not necessarily better than a substance that is used in high amounts. The HI1 does not look in any detail into factors such as acute toxicity. It does not look into reproductive toxicity, cancerogenity, and etc. And it also does not sufficiently ask about dangers to humans. And similarly, it doesn't look at the effects on the environment. Another aspect that is particularly problematic from the organic farming sector's point of view is that the HI1, as Martin already explained, does not look at how large an area has been treated with an active substance. It does not tell us how many hectares a pesticide has been used on. So if we compare only quantities used, expressed in total mass of active substance, and we do not consider the hectares of crop treated, this gives us a distorted picture of what is actually happening. So unfortunately, this HI1 indicator looks only at aggregate data and total mass of pesticides used. This means that the HI1 would actually increase and not decrease if more crops were treated with substances for organic farming instead of substances for conventional farming or synthetic pesticides. Generally speaking, as I explained, they are used in smaller total quantities. So the HI1 indicator promises to measure pesticide use and risk, but it does not deliver well from our point of view. And we think we need a method that looks more realistically at pesticides, that looks at the area of crops treated and at different parameters such as human and environmental toxicity parameters. Substances that are used in organic farming would score relatively better and thus contribute proportionally less to the total score of an indicator that measures pesticide use and risk properly. And on the slide, you can see an example. I hope it is legible. It is very small. Here, I'm similarly as to what we saw in the video, I am comparing two substances. Both are used for the treatment of powdery mildew in vineyards. Powdery mildew is also known as oidium. And in conventional viticulture, it can be used with a substance called penconazole. You can see it in the upper part of the slide. It will be applied 1 to 4 times per season. And the application rate can be as little as 0.025 kilograms, so 25 grams of active substance per hectare per application. But obviously also in organic farms, in organic vineyards, a treatment for oidium can be necessary. And then typically the active substance sulfur would be used. And here the minimum application rate of active substance, it's you can see it in the lower right-hand part of the slide. So the minimum application rate would be 2.56 kilogram per hectare or higher, and there are up to 8 treatments allowed per year. So in our example, a 4-hectare conventional vineyard would be treated with 100 grams of pesticide active substance, and a 4-hectare organic vineyard would need 10 kilograms of active substance. The total amount of pesticide used that would be reported for the HI1 would then be 10 kilograms and 100 grams. And I think it's easy to see that to achieve pesticide reduction with the HI1, it would make more sense to stop using the sulfur than to stop using only the 100 grams of penconazole, because this would not have any significant impact on the total score of the HI1. So I think this illustrates that we believe that the method is not a fair method to look at attempts to reduce pesticide use and risk. And IFOAM Organics Europe is looking forward to progress on biocontrol. We hope for a new legislation that will be proposed on that, but we also think we should not forget that action for pesticide reduction is still important and still needed. So we ask the European Commission to propose a new indicator that better reflects reality. And I think we can get some good inspiration for that from Helmut in a little moment. And yeah, I would like to close by saying that IFOAM Organics Europe's point of view is that the best way to reduce pesticide use in Europe is to promote organic farming. Yeah, thank you to all of you for listening, and also thank you to the Eden Foundation that has been funding the study that lies behind today's webinar. And I'm happy to now give the floor to Mr. Aidan O'Connor from Zintl. Thank you very much.
Good morning, Maria, and thank you for giving me the opportunity just to say something. My intention is going to intervene on this part of the discussion in relation to the current HRIs. I just want to say that I think some of the claims made about the current HRIs might be somewhat unjustified, and a few important elements need to be added, I think, in order to give a fuller picture. I think Martin has alluded to it already, that the HRI methodology was indeed adopted with the support of the majority of member states. So that's an important factor. It's also fully transparent. In other words, the methodology, which is adopted by means of a directive, is published annually alongside the latest update graph. So people can see exactly what constitutes the graph. Of course, we all recognise that the main constraint on developing an EU indicator is the availability of harmonised data. At this moment, the best available harmonised data is in relation to sales. That was the reason why the indicator was based on those data, which are very robust. Now, the Commission, that's not to say the Commission doesn't think that the HRI couldn't be improved. It does. And we've already given a commitment that we would make efforts to either improve existing HRIs or indeed develop new indicators. So this is work which is ongoing, and we're assisted in this by the JRC, who are working on this. And then there's further development in the pipeline. And some of you will know that the regulation on the agricultural inputs and outputs, the regulation on that will for the first time bring us in data on use of pesticides in agriculture. And that will be a huge asset. The data there will begin, it won't become available on day one. Obviously, it'll take some time to build up. But from 2028 onwards, for the first time, we're going to have some data across all the EU on the use of pesticides. And that's something which we consider to be very promising. It'll give the possibility either to further improve HRI separate to what the work is already ongoing, or indeed to make some new indicators. So there's hope there as well. Of course, we're always interested to hear ideas such as the ones already expressed about how we can improve HRI. And I'm particularly looking forward now to hearing from Dr. Buscher-Shannon. But just to come back to one point raised by Martin, and I just wanted to update him on that, that since the SUR was withdrawn, I can indeed assure him that the refocus with us and our team is on the enforcement of the SUD. So that's a post-SUR situation. But thank you for the opportunity for just making these very brief remarks. Thanks indeed.
Thank you, Mr. O'Connor, for this statement. I think I'm happy to hear that the Commission is thinking and working about improving the HR1. What I do not really agree is that there is any possibility to defend this measurement, and I think this will also become a bit clear in the end of my presentation. Now I will start with my first slide, which is requirements for a suitable indicator. My name is Helmut Buscher-Schaden. As I said, I'm a chemist, biochemist working at Global 2000, and in the next 50 minutes, I will try to present to you for the first time a new indicator that has been developed by IFOAM, Organic Europe's, and Global 2000. And this collaboration started already 2 years ago when it became clear that the highly problematic HRI1 was supposed to become the measuring tool for pesticide reduction under the Sustainable Use Regulation. Many stakeholders, also scientists, authorities like the Environmental Agency of Germany, the UBA, worked on improving this indicator. One solution developed in a slightly modified way by the UBA and us consists essentially of 2 key elements. It's the elimination of this really deceptive weighting factor 64 for pesticides that are no longer authorized, and the conversion of sales data into an area that is treated by the pesticide sold. So treatable area is it? And the weighting of risk factors of the HRI1 as it was proposed, or is it proposed? And of course, I agree with Mr. O'Connor, it was adopted by the member states, and it was not really the fault of the Commission that this indicator came out. But I think it's not possible for the Commission to use such a deceptive indicator. So then don't adopt any indicator, but not that one. Yeah. So given these problems, we aimed, so the risk factors have been retained by the model of the UBA and also for our model to repair in a quick fix the HI1. But of course, these risk factors that are only based on the authorization status are not based on toxicological data, as Maria already said. And therefore, we aimed to further improve the already improved version. And instead of only giving 3 weighting factors for the 3 groups of pesticides, each pesticide active substance should receive an individual tailored risk factor, which is calculated using a selection of ecotoxicological, human toxicological, and physicochemical parameters. The requirements we set for the indicator were transparency. And yes, I agree that transparency is already something. So now I try to, yeah, now it works. It's something that is also provided by the HR1, but it's not transparent for people who read in the newspaper that the pesticide reduction is already 46%, or see the graph how this data came to this conclusion. Yeah, so it's not a transparent indicator actually. I have some problems to move my. So now it works. So robustness is the next parameter that is important. We want an indicator that gives reliable results, whether a substance is of natural or of synthetic origin, which is not the case with HR1. We want an integrated assessment. The indicator must consider risks to both human health and the environment. And last but not least, it should be also possible to have specific queries, such as trends, for example, in bee toxicity or in the use of pesticides only, or in the combination of use and risk. In the following, I will present the preliminary results from this project, a simple indicator, which we call, and I will call it in the following PURI. PURE stands for pesticide use and risk indicator. And this indicator is quite new, as I said before, as new so that the name it received only yesterday. So I was not able to even contact my colleagues and ask them. So I would say let's talk about some kind of a working title when we call the indicator PURI. Central to the indicator is, and this is the starting point for everything, is the area, the treatable area. a treatable area associated with a specific active substance I. And this area is obtained, as we have been, as we saw in the video, by using the sales data as a starting point, as the HRI1 does, and then multiplying the sales data with the hectare application rate. I will not go into further detail on that. The treatable area then is multiplied by a risk factor. And this risk factor, we call it risk factor for environment and health risks, is derived by data so data for environmental toxicological aspects and health aspects, and it combines out of two risk factors that are added together. And for deriving the environmental risk factor, before we come to how these risk factors are derived, the indicator in itself is calculated by multiplying the treatable area, so TAI, by the corresponding risk factor for each active substance and summing these products up for all substances. So this to be complete here. And for deriving the environmental risk factor, the RFE, we use data on the toxicity of the respective active substance to pollinators, to birds, to earthworms, to mammals, and to aquatic organisms, as well as data on the persistence in water or soil. And the source of this data, and this is the pesticide property database of the University of Hertfordshire. And I assume many of the people here know this database and have already worked with it. It contains predefined, for example, predefined data ranges for all the original data for each of the aforementioned parameters and classifies them into high, medium, or low risk. For example, the toxicological data have these three classes, P toxicity or toxicity for birds. And what we did is we defined point scores for these ranges. So we used 1 for high, 0.5 for medium or moderate, and 0.05 for low. So thus we have 5 sub-risks that when summed can yield a maximum score of 5. As normalizing step, the term is then divided by 5. So that's what we do in the end when we calculate the partial risk factor for the environment. The second example is, or just very briefly to show how the risk factor for, before we go to the risk factor for health, we will do a small calculation, a very brief calculation with the example of cypermethrin. So environmental risk from cypermethrin. As you can see, cypermethrin is highly toxic for bees and also for aquatic organisms. It's of low toxicity according to the pesticide property database for birds, and it's of medium toxicity for earthworms. And because the persistence is multiplied as it's considered in this assessment, because the persistence in soil is low for cypermethrin, other than the persistence in water, the whole toxicity for earthworms is further reduced by this factor. So, and now we will briefly perform a similar exercise for health toxicity, the data used for this. So this is the second factor that we use for deriving this PURI, this pesticide use and risk indicators. The data includes the hazard-based GHS classifications. So these data are available in the EU pesticide database for carcinogenicity, mutagenicity, reproductive toxicity, as well as specific target organ toxicity, acute toxicity, and health-based guidance values for chronic toxicity, like the acceptable daily intake and the acceptable operator exposure level, for example. And the resulting risk factor for environment and health for cypermethrin, as we can see, is shown here. It's 0.87. So actually those risk factors are higher, greater than 0, and lower than 2 as a maximum. These risk factors are between a bit more than 1 and a bit above 0. So what you can see also is when we look into 16 such risk factors, they are quite different depending on which chemical or which natural substance we use. We do have natural substances that have relatively medium or high risk factors, like, for example, the pyrethrin, which is the prototype of the pyrethroids, also insecticides that are nerve toxins. We have low risk factors for something that we eat in our salad. It's the rapeseed oil, for example. We can see it here. It's 0.07, and we also have low risk factors for baking soda. Sulfur, on the other side, is in the intermediate rate, and we see here, for example, sulfur is in the same range as glyphosate. I think this is does not reflect the reality very well, but everything, of course, is based on the data that we have, and we know that with glyphosate, the official data say glyphosate is completely harmless, and therefore the indicator gives us this picture. Yeah, I don't want to go into more detail on that now at this point. With this indicator, we can now, or with these risk factors, we have shown here risk factors for 16 substances, we can now calculate the purity. But before we do that, we use these data of 16 substances to calculate the harmonized risk indicator. So we see what this indicator is showing us. And according to this indicator, there's one dominating substance dominating for the overall risk, and it's sulfur. It's the light green bar that you can see here. And the differences in risk from between different years are only resulting from sulfur. But when you do the calculation of the area that is treated with all 16 different pesticides, then you find, okay, sulfur is not important. So it's important, but it's only about 10% of the overall area that is treated with sulfur. The rest is treated with other pesticides. So what the HRI1 tells us, the story is not correct. And also, it doesn't show us the real trend of an increase in use, which here with treatable area calculation is shown. So knowing this, we can have a look into the next calculation of our new indicator, the purity. The purity shows us also an increase in risk that is to some degree, not only to some degree, it correlates to the increase of use, which is no surprise because there was not so much change in the pesticides use, but there was one change. The most dominant change was the increase of use of cypermethrin, which is also an insecticide, a synthetic insecticide, which has high toxicity for bees, for water organisms, and therefore this yellow bar that we can see here is increasing because the amount of cypermethrin is increasing, and this leads to a higher increase in risk than in use. So increase in use is 200%, increase in risk, when you look into the data, it's 220%, so slightly more. If we go into more detail or in a special inquiry of the risk to pollinators, so this indicator, this is one of the things that this indicator is able to do. You can look for risk to earthworms, which is, we don't show the data here, but the risk for earthworms has decreased compared to as a relatively decreased. The risk to pollinators between 2011 and 2022, but only with the 16 substances, has increased by 270%. So this is just in this example, and here this disclaimer, this example is based only on 16 pesticide active substances because of different reasons. One reason is that we do not have yet a database to calculate everything at once. So it's still some work to do this, and also it's easier to and more transparent to see the single active substances here. So finally, I would say one of the most important feature of this indicator is that its robustness and its resilience. Yeah, so you can measure natural substances that are used with 5, 10, 20 kilogram hectare application rates, like rapeseed oil. You can also measure substances that are used with only 10 gram per hectare, where you have a 10,000 or 3-4 orders of magnitude difference. And many other established indicators have a problem with that. And I think, given the EU's goal to adopt, also the EU's goal to increase the use of low risk pesticides, to substitute them, to substitute the candidates for substitution, and to increase organic agriculture in the European Union by 25% until 2030. And all these goals are still valid goals. We need an indicator that is showing this. And here we developed a LACMUS test. I will briefly tell you what it is. We start in a given area, or could be maybe just a country, where you have 100% use of synthetic pesticide on the agricultural area. And to make the example simple, because it's a LACMUS test, it's super simple, we use only 3 different pesticides to represent the fungicides, penconazole, the insecticides, this cypermethrin, and a herbicide with a very low hectare application rate, fluorosolam. And this is the starting point. So this starting point has a risk that can be measured by different indicators. What happens if in this special situation, there is an increase in the application of natural substances, for example, because organic farming will be established? Yeah? We assume, which is not correct, that 100% of the organic farmers would use pesticides for all cultures in the same way that the conventional did, but replacing synthetic by natural substances. This is just for this example. And we go further and say, now we have 25% organic area, which is the 2030 goal of the Farm to Fork strategy. And in the end, this is what Martin said, Safe Bees and Farms, the Citizens Initiative, wanted it to be that. So what do different indicators tell us about this? And now this is really an interesting picture that you see. This is what the HRI1 tells you. The HRI1 tells you that as long as only synthetic pesticides, and maybe you did notice that there was a candidate for substitution among those, it was the cypermethrin, there is almost no risk. The risk starts when you use rapeseed oil, something that you put in your salad. And this is what the HRI1 is giving you as a result. And therefore, please do not try to defend this indicator. Nothing could be more deceptive than this. And you have in the end, 40,000%, so 400 times higher risk with using natural pesticides than with using the synthetic ones that are candidates for substitution. When you use a meaningful indicator, and the Pure is, I think, a meaningful indicator, you see that the risk is decreasing. It's not going to zero, because also in this case, it's the sulfur. Sulfur has also a negative impact on biodiversity, mostly on biodiversity. And this is reflected here, but not that much as other pesticides. And for example, you get rid of the insecticide. The insecticide is responsible here for the high starting point in the conventional area. So here is only for interested people the data to do the LACMUS test with other indicators. I think whatever indicator will in the future be used, also under the SIO, when we have use data, or before we have the SIO to replace the HI1, should undergo such a litmus test. And if you have an increase in the risk by using substances like baking powder or rapeseed oil, which are important in organic farming, then yeah, you should not apply this indicator. So last slide, of course, there are still possibilities. Every indicator has its limitations, and no indicator can be better as the data that we have, and also the way how the data are applied offer possibility to further improve it. So to make it short, there could still be the fine-tuning could be improved. I think we are open for discussions on that. We also are thinking, have been discussing about considering more data than we already did, for example, something like a bioconcentration factor deriving from the pesticide property database. Sky or eye irritation could be a proxy for amphibia toxicity, because amphibia are currently not covered in the approval process. Also, an additional score to partially reward low replication rates, which is currently not in the indicator, could be discussed. So these are things that we still think about, but the indicator in its simple way, and simplicity is also, I think, something that is has its advantages. Is in my opinion a working tool to show what pesticide use and risk is. And yeah, I want to thank you for your interest, and in the name of my colleagues who helped me developing this and will do it in the future, Thomas Dorsberger and Dominic Lienhardt. Thanks.
Thank you to the speakers, and thank you, the audience, for your attention. Now I'm opening the Q&R session, so feel free to say what you want to say, but please tell us your name and your organization. On the other hand, you can also write questions or comments into the chat. Please.
There is one hand raised by Bartosz.
Okay, so please, Mr. Bartosz.
Yes, hello. Thank you for this briefing. My name is Bartosz Brzezinski. I work for Politico. I have a question. Politically speaking, if the Commission is kind of able to now say that it's on track to achieve this Green Deal goal or Farm to Fork goal of having pesticide use and risk by 2030, how likely is it that it would be open to revising this if in fact the reality is, as you have presented today, that in reality we're far from this ambitious goal? And so how do you convince the lawmakers?
Is this question addressed to the Commission a bit, or more to NGOs?
To both. If the Commission is also here still, if this
yeah.
Otherwise it's to both.
So maybe I will start very quickly. I think, as I said, this indicator is not defendable, and also as Martin said, having such a deceptive, and we really use this word not without thinking what it means. Yeah, it's deception. Maybe it's not. It was not what the Commission meant to do. So the way how this indicator was developed, all what we heard, the Commission was working and also pushing for a meaningful indicator, but it was not possible. And it took the Commission and the whole European Union 10 years to have this indicator, because the indicator is linked to the Sustainable Use Directive, which was adopted in 2009, and only 10 years after we got this indicator, which is in Annex 4 of the Sustainable Use Directive. So 10 years it took the Commission to find a compromise. The fact that this compromise is as it is yeah, it's a shame. You can't say it different. So I think it's not to be defended, and therefore the Commission has to come up with something that works. Also, the scientists say this. The Joint Research Center, I think, also made very clear that the HR1 does not work. The question is, of course, if you want to tell the people a story that is not true, then you would be motivated to keep this indicator. But I hope that this is not the way how European policy works in the moment. I hope we are not yet there. Yeah. So therefore, yeah. But I'm also curious what the Commission representative, Mr. O'Connor, maybe can comment to that.
Thank you, Helmut. Mr. O'Connor, do you want to contribute?
Yeah, just to say two things. Number one, that the farm to fork target of the 50% reduction is non-legally binding, and there is a related indicator to that. It's not exactly the same as the HRI1, and as Helmut has just said, the HRI1 is in the SUD, and the SUD calls for a continuous reduction in risk and use of pesticides. So it's not an end point; it's a continuous process. Thanks.
Any other questions? Okay, I'm giving the floor to Eric Gall from IFOA.
Yes, hello. I also represent IFOAM Organics Europe, and I wanted to ask a question about the opportunity which is given by the regulation on agriculture statistics, that SIO that was mentioned, that we will have from 2028 onwards actual data on pesticide use. But like someone said, maybe this data will not be available from day one. So my question to Helmut and the others is that, could you clarify that it is actually possible to come up with a new methodology based on data which is already available, and the fact that we should not wait for this new data on actual use, but we can already improve the indicator with data on the pesticide sales on the one end and the application rate on the other end? So my question is, do we really need to work 2028 and this new data on pesticides use to act to develop a new indicator?
Yeah, my answer is clearly no, we don't have to wait. I think we cannot wait, given the fact that we have currently a deceptive indicator that is pointing into the completely wrong direction and informing decision makers, authorities in the wrong way, but also the public. And of course, you can have meaningful results based on sales data, but you have to calculate the sales data correctly. You cannot say 2 and 2 is 7. That's wrong. And this is what the HRI1 is doing.
Yes, and if I may add to that, Eric, indeed, we were supposed, I think, for 2027 to have the first data on use by farmers. But there is a push now in the council to postpone by 2 years to the provision of the data by farmers. So it is not sure at all we will have them in a near future. So indeed, we have all we need to start working on using a better indicator. And then, of course, it will be refined once we have the uses per crop. But we don't need to wait for that to change indicator.
Okay, thank you. I can see another question by Jörn Strassemeyer from JKI.
Yes, hello. My name is Jörn Strassemeyer from the Julius Kühn Institute in Germany. And Yeah, I just thank you for this presentation. I think there was a really nice and clear presentation. And yeah, it's more not a question I have, it's more a statement. I think it's a really good approach to like calculate the sales data using these toxicity related risk values and also the application area. I think I said that already years ago when we have a tool in you can take a look into that at JKI where we compare a number of different indicators, also the harmonized risk indicator based on the German sales data. And I think it's really, I mean, there's different approaches we promoted based more on the pesticide load index in Denmark, but I think the approaches are very similar. You need a realistic assessment of the toxicity of the indicators to give a risk score. And there, as you said, it can be discussed which endpoints or which toxicity values go into the indicator. But I think that the most important thing is that we use this information we have already on the toxicity and also not go on the pure sales data, but also look at the application area or the area that is related to apply these sales in the country. So I think I agree very much with the kind of indicator. I didn't see the details so much now, but I think that's a point we really have to discuss on European level, which endpoints go in. And also another very important point you mentioned in your database is that in your talk is that we need a harmonized database to calculate. We have now the pesticide property database. That's right, but it has to be an official database which is given by the European Union. So everyone has the same data. Thank you.
May I just shortly answer to this? Yeah, I feel really honored by hearing this from you, being, I think, the most experienced indicator expert in the German-speaking room that I know about. So, and I was not aware that you had this very positive opinion on considering the hectare application rate in order to develop. I know that you were open to this approach. We had once a discussion 2 years ago that I remember, and yeah, so yeah, I'm happy to hear this, and I'm also very open to share all the data as soon as we do have, and all the as soon we can publish it. Yeah, as I said, it's a very new baby still. But the method stands, and yeah, I also think we need harmonized data. And the good thing is the member states and also the Commission has access to much more accurate or more recent data from their whole Wirkstoffprüfung, how do you say? The assessment of the active substances on the harmonized on the EU level. So of course there could be a database that is exclusively filled with data from the EU approval procedure. If this data is made publicly available, then the indicator can be transparent. But as long as we do not have this, I think the pesticide property database is a very trustful, useful, and also within the scientific community quite well respected. I don't know how if this is the right word. Source of data for such indicators. Yeah.
Thank you, Helmut. I can see Jutta Kinsle from FÖCO.
First was Mrs. Pop. Julia Pop was first to me. Was prior to me.
Yes, hello. Can you hear me?
Yes, please.
Hi.
I'm sorry, I did not see you. Please
No
go
worries,
ahead.
no worries. So Julia Pop is my name. I am coming from Eurostat, and I'm the data manager for the pesticide use statistics. I saw some questions related to SAIO, and I would like to clarify some things. Somebody was asking about the basket of the products. So indeed, the new SAIO will collect information on crops. So the use of pesticides by crops. We are having in the basket 21 crops, which were agreed and together with the member states to have the best coverages possible. And the countries will be also allowed to provide other crops, which are national important from the surface or the use of pesticides. I would also like to thank you for the presentation made for the new indicator, and I appreciate that we will have the chance to have a good look at this one. I saw there, but I a bit missed the first part with this area, a total area used in your calculation. What I want to say that the pesticides use, which indeed will be available from 2028 onwards, in this we will not collect only the kilograms of the pesticides, but also the hectares to which they are applied, having a methodology that it's taking into consideration this exclusion of the double counting, because you all know that the pesticides are given more times on the same area. So for us was very important to develop a method in which we are completely taking aside the burden of the double counting. So the hectares are the real ones on which the pesticides were used. Thank you very much.
Please, Julia Pop, go ahead.
Julia Pop, or do you refer to me?
Jutta.
Yeah, Jutta Kinsle.
Yes.
Okay, thank you. Well, I think
I'm sorry.
Sorry. I'm speaking for a farmers organization in Germany for organic farming, and I think we have to think about that. We will need a lot of time if we wait for the SIO to be implemented. And then we wait for a harmonized database, because you will have a lot of problems. We know this from what Mr. Strassemeyer is calculating. You have if you want to compare the pesticide, or you use in each case the tier 1 studies, and then you have a problem because they are very often unrealistic, or you start to use each available study, and then it's very important how many money the person spends to register, to authorize this product. And so you will have a lot of time passing until you have a real reliable indicator. So I think what Martin Dermine presented at the beginning, to say, let's change this kilogram to the amount per hectare use. This would be a short-time solution, and then you can think about long-time solutions, harmonizing the database and using the SIO data and so on. But I, being a person, elder person, will not see this indicator because it will last a long time. But we cannot wait so long to have really reliable data and to have a basis for the discussion. So I would go in steps, make the first make the first thing to go, and this is possible very, very quickly, to change the HRI in indicator that is based on hectare values and not on kilogram, and then go in a second way in another indicator. Thank you.
Maybe I can comment or answer to both of you, Ms. Pop and Ms. Kinsle. Yeah, I also think the hectare application rate as a factor that you need to get from kilogram to area is the crucial thing. And I think Ms. Pop said she did not understand really the approach that we took. It's very simple. You take the sales amount and you divide the sales amount by the hectare application rate. It's simple so far, but what is not so simple is to decide what is the hectare application rate for a given substance, for a given active substance, because active substances do not have defined hectare application rates. It depends on the product that the substance is in. It depends also on the crop this product is used for. It's different for example, for arable crops and for fruit, for trees, apples, orchards, for example. And therefore you have to define a method to determine this standard hectare application rate, but these methods do already exist. And so there is the NODU, there's the Danish Treatment Frequency Index, and we as a group of NGOs together with IFOAM, we just made some slight changes to the NODU model to make it more easy, and I think without losing information there. So there's a possibility to use the database of member states in order to generate this hectare application rate that you need for this fix of the HR1 to get area instead of kilogram. But there's also a different method which has been published by the German Environmental Agency, UBA, which I'm very happy about. They took a more simple and elegant approach than the NODU, by just referring to the harmonized data, so to some degree harmonized, the representative use data from the approval of active substances of the European level. So also this method has its shortcomings, its limitations, but it's overall so much better, than to just refer to kilogram in any way, even if I have a mistake, maybe 100% mistake for one substance, 50% for the other. All in all, over 500 substances, the trend is correct. So you have not a systematic mistake, and therefore I think the data is there. We only have to agree that we go this way, and then we have to agree which method do you want to operate with. Harmonized data from the representative users. The method has been already shown how to get to these, or take the NODU approach. But yeah, I think there is no way in the moment to do it different when you have these hectare application rates, and you want to be fair to natural substances and fair to organic farming, and enable the transition away from these synthetic pesticides to other forms of agriculture. Yeah, that's enough to say.
Helmut, thank you. Regarding the time, we have to get to an end, but I would say I allow Harriet Clayton to speak. And then I would also like to answer two questions sent on the chat. And then that's the end. Further questions can be asked by chat. So please, Mrs. Harriet Clayton.
Hi, yes, good morning, everyone. Thank you. I had a question in the chat, but I can just clarify here. I think that, of course, we have a lot of information, a lot of suggestions coming to the Commission, but I wondered then, Mr. O'Connor, you mentioned that the Commission is nevertheless working on and always open to improving indicators and so on, but I wondered, is that based on then the existing data? Or are you, to what extent are you relying on the SIO working as foreseen? Because as another participant mentioned, this is looking a bit shaky if the Council is not really getting ahead with the harmonization and the digitalization on time. So I just wondered to what extent you're relying on improving using the existing data that we have. Thank you.
Thanks, Harriet. No, they're two separate processes. We're not waiting for SIO. We understand that it'll have a great positive potential. But in the meantime, we're looking at other possibilities as well.
Okay, thank you. Thanks,
Thank
everyone.
you. So I'm going to read the first question sent in by chat. What is the possibility of authorities to embrace the methodology of PURI proposed? Who is going to answer this question? Helmut?
How do you say deflected?
Okay, shall I read the question again, or can you
Yeah,
read
please,
it in the
please.
chat? Okay. The question is, what is the possibility of authorities to embrace the methodology of PURI proposed? You can read it in the chat.
Also, the only thing that we can do is offer it. Yeah. So I think the first step in offering it was this webinar. We will, of course, before the end of the year, summarize and describe this indicator. We will publish the method, at least on our website. I do not know if we also are thinking about doing it in a scientific paper. And we are very open to discuss with people from the Joint Research Center, from the Commission, on how to, what could be meaningful tools. If this indicator is in these discussions comes under the scope, or is considered to be at least in elements be used as a meaningful indicator for to replace HR1, then we are of course very happy, because we think it's of course an indicator that would do the job, but we do not know exactly what currently is also done from other sides. So I know that there is an indicator under construction from the GRC. So also happy to get more information on that. There is also discussions on how to measure pesticide reduction or the risk of pesticide use on the global level under the biodiversity, also under the COP target to reduce the risk by 50%. So there's a lot of things going on. And yeah, my email address, I think it's available everywhere, and also from IFOAM. So please contact us if you are interested in discussing and also improving this indicator, because I think we need a solution for this.
Okay, thank you, Helmut, and thank you to all the speakers, and thank you to the audience for your attention. As I said before, you can still send in questions and comments via the chat. Yes, I'm saying goodbye.